Welcome to topic 5 of module 2. In this topic, we will be discussing the importance of feature engineering in three information security domains. Primarily, we want to establish this thing that machine learning is purely based on garbage in, garbage out. This means that whatever is input to the machine learning algorithm, that will be the output of your machine learning algorithm. So you have to put a lot of focus on the feature engineering part in machine learning. So selecting good features for anomaly detection is of paramount importance. And many algorithms of the anomaly detection will require an input in the form of a time series data. This we have already seen and discussed in the previous topics. Primarily, we will be discussing three information security domains for feature engineering. We will be discussing host intrusion detection system, we will be discussing network intrusion detection system, and we will also be discussing the web application intrusion detection. Anomaly detection is not restricted to host and network only. There are many other domains as well. Like for example, we have already discussed the fraud detection case and also the use of public API calls as well can be can be used to see that if there is any anomaly in that or not. So we have to perform good feature extraction both for fraud detection and also for public API use. When we look at the domain of host intrusion detection system, we have to collect the low-level events of the operating system. That is, we have to collect the signals which are collected from different sources in the operating system. OS Query, a popular operating system instrumentation framework that collects and exposes low-level OS metrics, and actually it is a set of scheduled queries that run through OS query and which allows us to establish a baseline of the host and application behavior. Basically, malware is the most dominant threat vector for host in many environments like in Linux, Windows, Mac. So we are looking for any malicious file that is running inside the system. Looking for indicators of compromise in the operating system is also the main feature engineering process as well. So what we do over here is that we look at the running processes or even their differences. So for example, at the time of running a malicious file, what was the count of the running processes? Was it increased from the previous count or was it decreased? Similarly, the kernel modules which were loaded at the time, the network connections, were they going up or down? Was there any port that was open at the time that the malicious file was running? What happened to the daemon, background, or persistent processes? Similarly, what are the entries in the registry databases? What are the plugins that are installed in the browser extension? And we will be very interested in the differences as well because we are looking for anomaly detection. So what we are going to do is that we are going to see the difference, and as we have the data available in the time series form in anomaly detection, so what we look at is that what exactly is the difference between any point in the history and between any point in the future. Active accounts, DNS lookups that were made, because whenever a malicious file is running, it try to hide the domain that it is connecting to. So normally it performs DNS lookups as well. It does not include any domain string in the code of the malware in order to hide the from the malware expert. Similarly, we have the system scheduler changes as well, startup operations or temporary file directory changes. So these are all the most important aspects that we have to consider when we are performing host intrusion detection system in the feature engineering of machine learning. OS query tool is basically running an OS query a daemon, and it is used for system reliability and any malicious binary file that try to reduce its footprint on the system by getting rid of its traces. OS query try to identify that file. OS query actually includes a set of very useful query packs. So these are the queries that are used to query different sources in the operating system, and you can get those results. So, for example, this is an example of the queries that can be made by OS query. You can have, for example, different deleted processes, or you can have the list of users which are active on the system. Also, you can have the five more memory consuming processes as well. So OS level events, OS query that OS query is also able to collect the low level events as well. So, for example, you can query for file system modification and accesses, the drives which are mounted, like, for example, the USB drives. You can also look at the process state changes as well and network state changes. So, in a nutshell, OS query can help you in feature engineering. So what you do is that actually you exactly pinpoint the difference that is going on within the integrity of a system. So OS query is the answer for feature engineering. However, there are few limitations of the OS query as well. The one point is that there is no built-in orchestration for or center deployment or control in the OS query. I mean, we are not talking about a single system actually. The host intrusion detection system has to run on all the system, almost all the important systems in the organization. So you need to collect the logs of all the systems. So we need a central orchestration point where we can gather the data, store the data, and perform the feature engineering. There are many alternative to OS query as well, which perform also a centralized deployment as well. And mature organizations are likely to have multiple servers in a variety of flavors deployed in a variety of environments. There is another alternative to OS query as well. One of them is Audit D, which is much more mature than OS query. And this is also a tool that is used by forensic expert. And also when we look at the context in the context of threat intelligence, for example, the MITRE attack framework mapping. So Audit D also has got some more than 30% mapping for the MITRE attack framework as well. This is another additional advantage. Once we have the feature engineering and all that aspect done, what we can do is that we can actually have a visual kill chain analysis as well with respect to MITRE attack framework.